Mm.
So we'll begin our lessons. Good morning, all of you. Okay.
Fine, sir.
Previously, we were discussing different methods of solving the transportation problem. That is to find out the feasible solution. So found that there are 5 methods to solve a given transportation problem. Transportation problem, as I was telling you, deals with the demand and supply situation. In a mechanical engineering industry, we take the supply of various goods to the showrooms to see that the customer demands are satisfied. Okay, so out of which we have discussed 3 different methods, that is the northwest corner method, row minima method, and matrix minima method. In those basic feasible solutions, we found out the first solution was led to a total transportation cost of 116,000 rupees, the next one 110,000 rupees, and the other one 116,000 rupees. Now we have left with 2 more different methods, that is column minima method and Rosal approximation method, to find the feasible solution. I don't say these solutions are optimum solutions. Let us try to optimize these solutions later on by different methods. First, let us understand which method gives a better solution by solving the same problem. So we were discussing a 3 showroom, a 3 factory and 4 showroom problem. I am continuing with the same problem with CMM, that is column minima method. You can see the movement of the cursor, column minima method. Okay. In the column minima method, so there are, as usual, there are 3 factories and 4 showrooms. Supply from each factory is given here: A1, A2, A3, B1, B2, B3, B4. So A1 plus A2 plus A3 is equal to B1 plus B2 plus B3, B4, 17, and it is a balanced table. Any method for that matter, the demand and supply problem, if you want to solve, it should be a balanced one. So the balance is already there. Now what we have to do is we have to scan the columns in a matrix. The scanning means you have to make the allotment column wise. You have to observe the columns. In row minimum method, we have observed the row in the matrix for allotment. So you have to scan the matrix. That's the meaning of this. Okay. So this is the matrix we have. See here. So look into the first column. So we have to make the allotment for the first column. That is, first column means it is the first room from different factories. In the first column, you observe you try to find out the least cost cell. That is least transportation cost. The first cell is having the cost 2, 1, and 5. Out of these 2, 1, and 5, the least cost is rupees 1000. That is in terms of 1000 only. You have to consider this cell in the first column. You have to observe always column wise only. You don't consider the rows. So it is a column minimum method, means the allotment must be made column wise. Okay. So we are making the allotment column wise. In the first column, the transportation costs are 2, 1, and 5, out of which the least cost is 1. That belongs to cell number 21. 21 means it is a row index followed by the column index. That is the address of the cell. Second row, first column. That's the meaning of cell 21, whose cost is 1. Now you try to make an allotment to this cell. Okay. This cell means I have to give it from factory 2 to this showroom. Okay. How much quantity you can give? Though the showroom can keep 7 units, I can supply only 1 unit of car or 1 unit of goods from this factory to this showroom, because the constraint on the factory is that its manufacturing capacity is only 1 unit. You see, it cannot supply 7 units. So therefore you supply only 1 unit here. Therefore you supply only 1 unit here. Okay, so that the factory 2 is exhausted. factory 2 is exhausted, but still the showroom is not yet filled up, because showroom can keep 7 units. Out of that, only I have delivered one quantity from factory 2 to showroom number 1. Still it can take 6 more units. Okay, that's what I have explained here in the theory, in the slide. Scan the matrix column wise. Select the least cost cells in the first column, that is cell number 21, whose cost is rupees 1. Hence, make the allotment to this cell 2, 1 in second row first column, keeping in mind the column and row constraint. So I have made this allotment, you see here, one quantity. So I have left it. Still, the first, only the second row was exhausted because the capacity of the factory 1, factory 2 was 1 unit. Still the column, we are in first column only. So now the first column, now we are left with 2 cross 4 matrix. This is exhausted, means you should assume this row is removed from you. So in mind you have to assume this row is not available for further allotment. That is, second row is not available for further allotment. We have the first row and the third row. Okay, we have the first row and the third row. So in the first row and the third row, you have to consider only the first column. The cost is 2 and 5. So 1 is already filled up, you see, in the first column. So because the showroom number 1 can still take 6 more units, you have to first finish the first column, then only you have to move to the second column in a column minimum method. In the column minimum method, okay? In the column minimum method, you have to do that way, okay? So now I'll go to the first column. The remaining cells are the cell number 11 and cell number 31. Out of that, the least cost is 2. So you go to this cell, that is cell number 11, and you make an allotment, keeping in mind the column constraint as well as row constraint. Now the factory 1 can supply 6 units, and the showroom 1 can further, it can take up 6 more units, because 1 unit was given from factory 1. So you make an allotment of 6 units from factory 1 to showroom number 1, 6 units. So when you make 6 units of allotment from factory 1 to showroom 1, being this is the column allotment and the least cost cell of that column, so what has happened is the capacity of the factory 1 is also exhausted. So that's why I have shown it as a dotted line. And similarly, the entire capacity of the showroom is also get filled up. 1 plus 6 has become 7. Now this has gone and this has gone. Now this row was already cancelled in the previous allotment. Now I have left with only the third row. Third row, that too, the second column, third column, and fourth column. Only one row I have left with in the F3. Okay. So then just look into these details that I have explained here in the theory, in the form of a notes. See, the requirement of the first column, that is showroom, is not yet filled up. That's what I have explained. Because in the first column, when I made an allotment to cell number 21, only one quantity was allotted. Showroom number 1 was not yet filled up completely, because it is a column-wise allotment. So you have to finish the column allotment first, and then you have to move on to the next column. Like that only you have to do in the column-wise allotment. Okay. Column 1 is for column 1 only for further allotment. You have to consider column 1 only because it is not yet completely filled up. Therefore, I have considered. So the cell number 11 is still can still take 6 units that I have supplied from factory 1. Okay. Now both the call F1 is exhausted and column number 1 is exhausted, and this is the situation we have left with. That is cell number 32, cell number 33, cell number 34 we have left with. So in this cell, you go to the second column now. In the second column, the least, there is no question of, though there are 3 casts here, 3, 0 and 8, 3 and 0 were already crossed out because in the earlier allotments, only I have left with 8. So therefore you make an allotment here. So how much quantity I can give here? So from F3 can supply 10 units. F3 can supply 10 units, but the showroom number 2 cannot take 10 units because the keeping capacity of that is only 5 units. So therefore I have made an allotment of 5 units of car from factory 3 to showroom number 2. So showroom number 2 get exhausted. Now I have left with the cell number 33 and cell number 34. Go to the column number 3. Column number 3 means it is a single row, single column matrix like now, this stage. Okay. So don't don't go cost wise, you have to go column wise. In this column, 11, 6, 15 are there, but 11 and 6 are already crossed out because they are exhausted. Those two rows and two columns are exhausted. I have left with only this. Now you have to make an allotment of units from factory 3. So column 3 can keep, that is showroom number 3 can keep maximum of 3 units. So therefore, you make an allotment of 3 units to this showroom from factory number 3. So now this showroom is also get exhausted because all the 3 cars are given from factory 3 to showroom number 3. Now go to the last column, that is column number 4 or showroom number 4 can take only 2 units. That the remaining units with this are 2 units only. Out of 10, 5 and 3 are given here, only 2 units are left with. So you make an allotment of 2 units here, and the entire conditions or demands of the showrooms are met by the factories. Now the entire allotment is over. Now you calculate the total transportation cost. Total transportation cost is, this is the unit transportation cost in thousands of rupees. Means 2 means it is cost of shipment of 1 unit of car from factory to showroom number 1. But how many units we have shifted? That is 6 units. This is like X11. This is X21. This is X32, X33, X34. So multiplied by corresponding transportation cost. X11 into C11, X21 into C21, X32 into C32, X33 into C33, X34 into C34. That's what I have done here. So number of units multiplied by the transportation cost. 6 into 2 is 12. 1 into 1 is 1, 8 into 5 is 40, 15 into 3 is 45, 9 into 2 is 80. The total cost becomes 116 in terms of thousands of rupees. This is again by column minimum method. The basic feasible solution is 116,000 rupees. Okay, so this is almost like a northwest corner method or the matrix minimum method. Solution now improved compared to the other methods. The last method we will see, that is the Vogel approximation method. So Vogel approximation method. Which method? This is the last method by which you can find a feasible solution. I don't say optimum solution. Okay. So let us see what is optimal solution later. So we'll consider the Vogel approximation method. V for Vogel, A for approximation, M for method. This is also called as VAM method. The other name for this is also called as penalty method. Remember, Vogel approximation method is also called as penalty method. So I have considered the same problem of 3 factories and 4 showrooms with following capacities of the production capacities of the factories and the housing capacities of the showroom for a day-wise sales, okay, in 4 distribution centers. So the question here is, as the name itself indicates, penalty. What is penalty? What is penalty? In this method, one has to find the penalties. We have seen that in the northwest corner rule, we were not worried about the cost. We were considering only the northwest position. In row minimum method, we consider only the row. In the row which was the least cost cell, like that we have made an allotment. In column minimum method, we have considered only the columns. In each column, what was the minimum cost, and we have made an allotment. In matrix minimum method, we have considered the entire matrix, that is 12 cells. Out of 12 cells, which is the least cost and which was the next least cost, like that we have made an allotment. But penalty method is slightly different. We'll see what is the meaning of that. So as the name itself indicates, penalty method, we need to find the penalties. We need to find the penalties. So the penalties are the row penalties we have to find out and column penalties we have to find out. Okay, one has to find out the row penalties and the column penalties. Okay, row penalties and column penalties we have to find out. Okay. So there are 3 rows, and there are 3 row penalties. There are 4 columns, therefore there are 4 column penalties. Means to start with, there are 7 penalties to be found out. Okay. So then the question comes, what is penalty? Okay. What is penalty? Penalty is the difference of least cost and next least cost in a row or a column. It may be in a row or a column. Okay. So what is penalty? You try to understand penalty is the difference of least cost and next least cost. Okay. So therefore the penalties, as I was telling you, it is of two types. It is a row penalty and a column penalty. Okay. So let us try to understand what is row penalty and what is a column penalty. Row penalty means you have to observe the matrix in the row-wise fashion only. Row penalty is the difference of least cost, most minimum cost, and the next minimum cost in that row. It's clear. You have to be very clear. Try to understand this. Penalty means the difference of least cost and the next least cost in that row. Row penalty. Column penalty means you have to consider a column. In that you take the least cost, means minimum cost, and the next minimum, next least cost, and take the difference of those two values. That gives you the column penalty. And you have to write those penalties in the square bracket along the side of the row or below that column carefully. So I'm illustrating that in the coming area here. You see here, this is the 3x4 matrix we have, and this is a balanced TTP as usual. Now I'll take the first row. Consider the first row. Observe the first row carefully. The costs present in the first row are 2, 3, 11, and 7. Okay. I'm repeating. In the first row, you concentrate only on the first row. 2, 3, 11, and 7. You have to find the row penalty. What is the definition of row penalty? Row penalty is the difference of least cost in that row and the next least cost in that row. Okay. What is least cost? Least cost in that row is 2. The next least cost is 3. The difference of these two, 3 minus 2, that is 1. You have to write that penalty 1 to the right side, to the side of that row in a square bracket like this, 1. Come to the second row. You don't consider this cross line right now because they have already solved this. Okay, in the second row, you just look into the least cost. Least cost is 0. The next least cost is 1. Either this one or this one. Don't worry about that. Only consider the value. The least cost is 0 and the next least cost is 1. You have to start from the minimum value in the ascending order. The difference between these two, 1 minus 0 is 1. You write that value here. This is penalty, row penalty number 2. Penalty, row penalty 2. So there is 3 row penalties because there are 3 rows. You have to find the third penalty of the row. So in the third row, the costs are 5, 8, 15, and 9. Out of this, least cost is 5. The next least cost is 8. The difference of these two, that is, you have to subtract the lower value from the higher value. That's understood. 8 minus 5 is 3. That is the penalty of the third row, 3. That you have to write on the right side of the third row. Okay. Similarly, you have to find the column penalties. So look into this column penalty. So you have to look or you have to observe the matrix in the column-wise fashion. You forget about row fashion. Your eyesight should only concentrate column-wise like this. Okay. You have concentrate only on this D1 column. Don't look into the other values. The values you have to scan is 2, 1, and 5. What is the least cost? 1 is the least cost. The next least cost is 2. The difference of these two is 1. So that is the penalty of the column. This is C1 penalty, C1P. This is called as P for penalty, C1P. Now find out C2P, penalty of the second column. The least is 0. The next least is 3. So there are 3 values, 3, 0, 8. Out of that least is 0. The next least is 3. So the difference of these two is 3. Similarly, come to the penalty of the third column. The least cost is 6. The next least cost is 11. The penalty is 5 here. Okay. Similarly, come to the fourth column. This is the third column penalty. This is the fourth column penalty you have to find out. Least cost is 1. The next least cost is 7. Okay. The difference of these two is 6. So we have 7 penalties altogether. This was I was telling you to start with. 3 row penalties and 4 column penalties. Out of this, so it is in a L shape, inverted L shape. You consider these penalties, this is in a L shape, inverted. Regular L is like this This is in an inverted L shape. Normally we write like this. Out of these 7 penalties, you have to identify the highest penalty. That's very important. There are total 7 penalties, that is 3 row penalties and 4 column penalties. Out of this, you have to consider the highest penalty. The highest penalty is 6. The penalties are written in the square bracket. This 6, 1, 2, 6, 1, 10 are A1, A2, A3. Don't consider these for penalties. These are the capacities of the showroom. These are the capacities of the factories. Don't consider those as penalties. Penalties are written in square bracket. The highest penalty is 6. This is like an entering variable of your simplex method. Recollect your simplex method, which I have discussed in our regular classrooms. Okay, this is like EV, entering variable. Now you have to make an allotment. Where you have to make an allotment, that's a very important point. This 6 is the penalty. You know already 6 is the penalty. It is the difference of 1 and 7. Our objective is to minimize the transportation cost. So this 6 has come because of the difference of 1 and 6, 1 and 7. Out of this 1 and 7, which is the least cost? 1 is the least cost. To this cost, you have to make an allotment, keeping in mind the row constraint as well as the column constraint. Okay. Now you take this cell is this based on the penalty, you have to identify the cell for allotment. That is most important. So we have identified the cell number 24, second row, fourth column, because this is the one which belongs to the least cost assigned to the highest column penalty in this case. So the penalty may be anywhere. But the only thing is, out of these 7 penalties, you have to consider the highest penalty. So that highest penalty is the difference of 1 and 7. So you have to come to 1. So that is cell number 24. Now for cell number 24, while making an allotment, you have to keep in mind the row constraint, okay, row capacity constraint and column capacity constraint. Though column number 4, that is showroom number 4, can take 2 cars, I cannot supply 2 cars because the factory 2 capacity is only 1 unit. So you supply 1 unit here. The factory 2 is exhausted. The factory 2 is exhausted and have still the column number 4 or showroom number 4 is left with an allotment of 1 car because it needs 2 cars for its daily transactions, but have to fulfill 1 more car later. Okay, this is how we have to do it. Okay, so next, what is to be done? F2 is exhausted. Now we are left with only the exhausted row. You have to remove. So you have to remove completely. So F2 I have removed. I have left with 2 rows, 4 matrix. Okay, look here carefully. See here, this is F2 row. This F2 row is exhausted. You remove this. The complete allotment of this row is over. Okay, therefore you remove that row and come to the 2 cross 4 matrix, remaining 2 cross 4 matrix. So I have left with the 2 rows and 4 columns. So I have 2 row penalties and 4 column penalties. Means I have to determine now 6 penalties. So as usual, penalty is the difference of least cost and the next least cost. Okay. As usual, the meaning of penalty is it is the difference of least cost and next least cost. So F1, F2, out of this, okay, so you have to find out a penalty now. In this row, 2 is minimum. Next minimum is 3. The penalty is 1. I have written here. Okay. Next here is the 5, and the next least cost in this row is 8. The next least cost is 8. So therefore the penalty is 3. Similarly, I'll go for column wise penalties. The difference of 2 and 5 is 3. Difference of 3 and 8 is 5. Difference of 11 and 15 is 4. Difference of 7 and 9 is 2. Out of this, you have to consider the highest penalty. There are 2 row penalties, that is 1 and 3. There are 4 column penalties, 3, 5, 4 and 2. Out of this, the highest penalty belongs to column number 2. This is like an entering variable. So you have to make an allotment. Okay. So here what I will do here is F1. So I'll take this highest penalty 5. This 5 is the difference of 3 and 8. So out of this 3 and 8, 3 is minimum. You have to come for this cell number 1, 2. Cell number 1, 2. That is first row, second column. So you have to make an allotment. So F1 can give 6 units of car. Undoubtedly, it can supply 6 units of car. But we cannot supply 6 here because the keeping capacity of the showroom number 2 is only 5 units. So therefore, I am supplying 5 cars from factory 1 to showroom number 2. And I have left with only 1 car for further. F1 can still supply 1. F1, the product, the supplying capacity of the factory 1 is 6 cars. Out of that, 5 cars I am given to showroom number 2. Still, I can give 1 more car. That's why I have taken and written 1 here. Okay. But what happened to the showroom number 2? Showroom number 2 is completely exhausted. It can keep only 5 and all the 5 I have fulfilled here. So therefore, you have to remove this showroom for the next allotment. Okay. So next we have left with only 2 rows and 3 columns. That is D1, D3, D4 and F1 and F3. So let us see here in the next allotment. See, the D2 is completely filled with, therefore I have left with F1 and F3, D1, D3, D4. Okay. Now, so I have left with 2 rows and 3 columns. Means I have to find out the five penalties, 2 row penalties and 3 column penalties. So what is the row penalty here? Before making an allotment, this crossed out and allotments are done only after calculating the penalties. To start with, this was the only matrix I had with the cast, 2 rows and 3 columns. So now you take the difference, 2 and 7. 5 is the penalty of the first row. Okay, next 5 and 9. The least cost and the next least cost in that row, 4 is the penalty. So likewise, column wise, you take the difference 2 and 5, 3 is the penalty. 11 and 15, 4 is the penalty. 7 and 9, 2 is the penalty. Okay. So there are 5 penalties, 5, 4, 2, 4, 3, out of which the highest penalty is 5. This is like an entering variable of your simplex method. It may be happening for a row or it may happen for a column. Depends upon the penalty and it depends upon the highest penalty where it is present. Okay, it's pointing to a row because it's a row penalty. So this 5 is because of 2 and 7. Penalty is the difference of least cost and the next least cost. Remember always. 2 and 7 in that row. So you have to come to the least cost 2 here. So F1 was out of 6 already I have given 5 units to the showroom number 2. That you must remember always. You should not forget. You see here I have left with only 1 unit. Though F1 capacity is 6, out of that 6, 5 already I have given here in the previous stage. See, out of 6 I have already given 5 units and I have left with only 1 unit. That you have to carry forward. That I am showing it here. Okay. Okay, see here carefully. See here carefully. So therefore, the capacity of 1 I have written as 1. It is not, originally it is not 1. Now at this stage it is 1. Because it was originally 6, the 5 already I have made an allotment. Okay, therefore that remaining 1 quantity I am making this allotment here. So to the least cost cell D1. So 1 if I make an allotment out of the 7, still 6 units showroom number 1 can keep. Okay. Showroom number 1 can keep still 6 units. Okay. Is it clear? So now determine the
Yes, sir.
5 penalties. So I have left with 6 units here and this row is, this factory is completely exhausted. Okay, somebody were asking me yesterday this question. This answer, is valid for all. Whenever you are left with either a single row or a single column, you need not to calculate the penalties or you need not to worry about the allotment method. You have to go with the least cost because our objective is to find out the least transportation cost. So now I have left with D1, D3, D4. I have not written here. D1, D3, D4. Out of that least cost is I have left with 10 units. So least cost is 5. So the further allotment to be made here is 6, 3 and 1. That 6, 1 and 3 all these allotments are made without calculating the penalties. Okay. Whenever you have a single row or single column, you take the least cost first here, 5, you make an allotment 6. Next, the least cost is 9, you make an allotment of 1, it is completely filled up, D1, this is D4, this is D1, and this is D3, D2 is already over actually. So this is 15 units. So the complete allotment is like this. So once you summarize all these allotments, what you have made based on the penalty is like this. From F1 to D1, from F1 to D1, 1 allotment. F1 to D2, 5 allotment. Totally F1 has supplied 6 units. F2 to D4, 1 unit. So the completely it is supplied. Okay, F1, F2 to D1. Similarly, from F3 to D1, it is 6 units. F3 to D3, F3 to D3, it is 3 units. F3 to D4, 1 unit. That's what I have summarized. So, and all the conditions are met, you see here. 1 plus 6 is 7, 5 units. This is 3 units. 1 plus 1 is 2 units. And we have to now determine the total transportation cost. So, entire demand and supply are met. 17 units are manufactured and 17 units are supplied as per the requirement of the showrooms. Now, what has happened to the cost, you see here? 2 into 1, 2. 5 into 3, 15. 6 into 5, 30. 1 into 1, 1. 15 into 3, 45. 9 into 1 is 9. What has happened to the cost, you see? Rupees 102,000 rupees. So this method has given you the least amongst all the methods. So therefore, as I was telling you, Vogel approximation method always gives a value very near to the optimum. I don't say this is an optimal solution. It may be optimum, I don't know. Further reduction may not be possible. It is all in terms of thousands rupees or lakhs of rupees sometimes in a big industry. Therefore, we cannot ignore. These are all the scientific methods. Okay. This method has given you the least transportation cost amongst all the methods. The first 3-4 methods, either it was 116,000 or it was either 110,000, 102,000 or 102 rupees in terms of thousand is the least cost. Therefore, Vogel approximation method has given you the least cost amongst all the methods. And now let us further check whether the solution is optimum or not, or further reduction with different arrangements. Is it possible to reduce the further transportation cost? We'll see that. So in today's discussion, we have discussed column minimum method. In column minimum method, you have to consider the allotment to highlight the discussion. So the least cost in that column, and you have to make an allotment. Once the column is exhausted, then only you have to go to the second column and you make the allotments. Go column wise and make the allotments. That's how we have obtained a solution in the column minimum method, the way we have done it here. See, this is the column minimum method, okay, that we have looked into to start with the column minimum method. So take the column minimas and make an allotment. In that sense, it has led to a solution of 116,000 rupees. The penalty method is also called as Vogel approximation method. Penalty means you need to find out every time a row penalty and a column penalty. Row penalty means it is the difference of least cost and the next least cost of that row. Column penalty means in that particular column, what is the least cost and next least cost you have to observe and you have to take the difference. That becomes the column penalty. To begin with, in a 3x4 matrix, we have 3 rows and 4 columns. Therefore, you need to find out the 7 penalties. Out of that 7 penalty, you have to consider the highest penalty for the allotment. That penalty may be present for may be of a column or it may be of a row, no issue. Whichever one is the highest, that you have to take. In our problem, to start with, 6 was the highest penalty, so that was a column penalty pertaining to showroom number 4 or column number 4, and the least cost cell was called cell number 24, and keeping in mind the row constraint and column constraint, we have made an allotment. While doing so, the factory 2 is exhausted. You must remove that factory and you have to take the remaining 2x4 matrix to determine the penalties. That is what I have done here. And again, we found out the penalties. Out of that, we found out the highest penalty was 5 and it was pertaining to cell number 1, 2. There, keeping in mind the row constraint and column constraint, I have made an allotment of 5 units of car. Okay. Now the showroom number 2 is exhausted, so we have left with 2 cross 3 matrix, that is F1 and F3 and D1, D3, D4. That I have written here, F1, D1, D3, D4. So I have made an allotment. Further, I have left with only one row, that is F3 with the D1, D3, D4 column. Whenever you have a single row or a single column, you need not to find the penalties. Just go on making the allotment with least cost, next least cost, and next least cost, and satisfy the capacity constraints. So, in a nutshell, we have shown here the overall allotment of the units from various factories to the showroom, and we have calculated the transportation cost that has led to 100. So, this completes the discussion. If you have any queries, please come to the queries. Okay, please come. Please ask your queries if you have any. Anybody? Nagraj? You can unmute yourselves. I have not. Okay. Any questions? Sharath? Sharath?
Yes, sir. Yes, sir.
Any questions? Have you understood column minima method?
Yes.
And any doubts are there?
No, sir. It's good.
What is penalty you have understood, Sharath?
Yes, sir.
What is the meaning of penalty?
So penalty is the difference of two successive cells in a row or column.
Having least cost. Having least,
Yes,
least and next.
Yes, sir.
Very good. Very good. Okay. Janardhan.
Yes, sir.
What do you mean by cell
Yes,
number 2, 1?
Cell number 2, 1, sir.
What is the meaning of that? Cell, I used to say sometimes, while explaining cell 2, 1 means what? How do you find that address?
Sir, second column, first row.
No. Second row,
second row, first column, sir.
Very good.
Yes,
very good. Okay. Very good. Karthik is there? Janardhan? Okay. Janardhan?
Yes, sir.
What was the cost, total transportation cost we have obtained from Vogel approximation method?
102, sir.
What is the other name for Vogel approximation method?
Penalty method, sir.
Okay. We'll stop today's discussion. Tomorrow also we will meet at 10:40, same time, okay?
Okay, sir.
Tomorrow's class is also at 10:40, okay? Okay, we'll stop here. Take care. Don't go away from the house because now another 2 weeks is very crucial, okay?
Yes, sir.
Try to be safe. Watch, even entertainment programs after the class. I don't say always you should be with online classes only. Be happy, but don't unnecessarily go away and take care of your parents.
Yes,
stay safe, okay?
Yes, sir.
Okay.
Yes, sir.
And I will be sharing the notes once this chapter is over, because every time instead of giving 3-4 slides I am preparing, and I will put it to your WhatsApp group, okay?
Yes, sir.
Don't worry about the material.